Alright, to complete the congruent statement, you have to match up the letters. So TS are letters 3 and 2 over here. So I'm going to write the third and second one over here. So it's ML with a segment bar. Angle N is the fourth letter, so that matches up with angle U. Make sure you're putting angle symbols. LM is the second and third letter, so that matches up with ST in that order. And VUTSR. So V matches up with O. U corresponds with N. T corresponds with M. S corresponds with L. And R corresponds with K. And then if these two figures are congruent, find the measure of the angle or the length of the side. So angle P matches up with angle W. So angle W is 80 degrees, so angle P has to be 80 degrees. QR matches up with XY, so XY is 3. WX matches up with PQ, PQ is 5. Angle Z matches up with angle S is 35 degrees. And angle X matches up with angle Q. So in this, I don't have angle Q over here, but I know that P matches up with W, so that's 80 degrees. And I know that R matches up with X, so that's 145 degrees. So I have to use last chapter that's a quadrilateral, it's 4 sides. So it's 360 minus 145 minus 80 minus 35 is equal to angle X, which is 100 degrees. And then down here, it says write a congruent statement for each pair of triangles. Name the postulate or theorem that justifies your statement, and if the triangles can't be proven, write not possible. So sometimes you're going to have to fill in reflexive, vertical angles. So right here, these two, WC is congruent to WC. The side is not included between the angles. So yes, they are congruent by angle, angle, side. They have 2 angles and the side is not included. And then 26, this one has 1 tick, 2 ticks, 1 tick, 2 ticks, and the angle is in between them. So this is by side, angle, side. And then 27 is the side is in between the 2 angles, so it's angle, side, angle. Down here, find the value of X and Y. So 31 is an isosceles triangle because these two sides are equal. So X would have to equal 4. And then to figure out what Y is, this is the vertex angle. So I do 180 minus 50, which is 130 degrees. So these 2 angles by Bate, these 2 angles are congruent. So if I have 130 left, I can divide that by 2 and you get 75 degrees. Oops, 65, what was I doing? Okay, 65. 65, 65 plus 50 equals 180. And then number 32, these are 2 sets of isosceles triangles. This one's isosceles, this one's isosceles. So to figure out what X is, these 2 make a line. So X is 180 minus 125. So X is 55 degrees. So that means that this triangle right here has to be 55 degrees as well. So to figure out what Y is, by Bate, these 2 angles are congruent. So I do 180 minus 55, which is 125, and I split it in half. So that is 62.5 degrees. That's what Y is equal to. And then down here, this is an isosceles triangle, and the theorem is that if this vertex angle, this is the vertex angle, is bisected in an isosceles triangle, these have to be 90. This has to be perpendicular. So Y is 90. We know it's bisected because these 25 degrees are the same. So then this triangle is, to get x, you do 180 minus 25 minus 90, which is 65 degrees. Okay, for the next one, I wrote down my givens, so I'm going to use these two, and they're already drawn in that they're perpendicular. So I write that angle PSQ and angle SQR are right angles. That's by definition of perpendicular. So if I know that they're right angles, then I can write the angle or triangle PSQ and triangle RQS are right triangles by definition of right triangle. So right triangles, you can use HL if you know the hypotenuses are congruent, which we have the hypotenuses are congruent. So we have the hypotenuses are congruent. So we need a leg. So I know the legs QS is congruent to QS by reflexive. So I'm going to mark that. So I have the hypotenuses are congruent and the leg is congruent to another leg. So now I can write that triangle PSQ is congruent to triangle RQS by HL. You can't use HL until you say the triangles are congruent. Alright, I wrote my givens. Now remember, if you have two parallel lines, I'm going to mark that this blue line is my transversal. So when you're given two parallel lines, look for alternate interior angles. Alternate interior angles have to be touching the transversal and the parallel lines. So then I know that angle GTA is congruent to angle SGT by alternate interior angles. So I'm going to mark those. And these sides also, these triangles also share a side. GT is congruent to GT by reflexive. So I can mark that too. 2 ticks. So now I have angle, or side, angle, side. The angle is in between the two sides that are congruent. So I can write that triangle GAT is congruent to triangle TSG by side, angle, side. Okay, I wrote down my given. There's only one given, but it's telling me a lot. So if I have ln bisects OLM, this means this blue angle is cut in half such that these two angles are congruent. So I can write angle OLN is congruent to angle NLM by definition of angle bisect. I also know that it bisects ONM. So the red angle is cut in half such that these two angles are congruent. So I can write angle ONL is congruent to angle LNM by definition of angle bisect. And the last thing I can write, they share same side. So LM is congruent to LM by reflexive. So now I do have enough information to write that the triangle is congruent. Triangle OLN is congruent to triangle MLN because the side that is in between the two angles, the sides are congruent. So this is side, angle, side, angle. Angle, side, angle. The side is between the two angles. Alright, this last one, I am going to use CPCTC. I know that I'm going to use CPCTC because we're asked for a side length or an angle or something besides the triangles being congruent. I need to first prove the triangles are congruent. So I have my first given, L is perpendicular to AB, and then L bisects AB. So if L bisects AB, I know that AC has to be congruent to CB by definition of bisect, and it's already marked on my diagram. Alright, and then I also know that PC is congruent to PC by reflexive, so I'm going to mark that on my diagram. And if they're perpendicular, it means that angle PCA and angle PCB are right angles by definition of perpendicular. So in this case, I'm not going to use HL. Even though I have a right angle, I can kind of see that I have side angle side going on. So before I can do side angle side, I have to show those two right angles are congruent. So I write angle PCA is congruent to angle PCB by all right angles are congruent. So now I can write the triangles are congruent. So triangle PCA is congruent to triangle PCB by side angle side. So side angle side. Oops, I should have put two ticks on here. Side angle side. So because the triangles are congruent, their corresponding parts are congruent. So PA is congruent to PB by CPCTC.